Oh, hi. Today I'm going to discuss the next question in the Leetcode Top Interview 150 study plan, that is traffic rainwater 2D. So there are basically two types of traffic rainwater. This is the easier one. So given n non-negative integer representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. So what this question basically asks us is if there are blocks, supposedly at 0th index it is 0, 1th index it is 1, 2th index is 0, third index it is 2. So we have to see how much rainwater at most we can trap between the cell. That is, if a cell is greater than like how much water is trapped between two bigger cells. That is, if this is bigger and this is bigger than the second index, that is 0, we can here trap rainwater. So the easiest solution we can do here is we can see for each index, start from each index. For example, we start from uh, 0. We try to make up the ends that we have, that the right end and the left end, and consider the lower end for computing the rainwater, because if in this case, as you can see, key the left end is lower than the right end, so only 1 unit of water is trapped, so we have to take the lower end and calculate according to that. But it would lead to a complexity of like every time we are computing from n, like on both side we are computing till the last, so it would lead us to a complexity of around n square. But we don't want that, we want an efficient solution. So the efficient solution which exists here is basically a two pointer approach, wherein we start the left pointer from the here and right pointer from here. And according to heights, we do some if condition, and therefore we are able to compute the solution. So it will be more clear when I actually write the code. So int L is equals to 0, int R, that is the right pointer, is equals to actually the last index in the height, that is height size minus 1. The int answer, that is the total rainwater we can trap, is initially equals to 0. Int L max is equals to 0, that is current highest leftmost index in during our iteration. Then we have int R max is equals to 0, that is the current highest rightmost index, the rightmost building basically, which can be used to trap rainwater. So we're going to do this until L is lesser than R. So for the first condition, what do we actually need to check? We need to check key if lower end, if left end is greater or the right end is greater, and according to that we'll compute our like if the lower left end is lower, we need to compute for this first, this part of the rainwater, because uh, it will be useless to firstly compute right part, because it is actually greater, and if the left part is anyway lower, we like can't trap rainwater in that. So if height L is lesser than height R, now that we have this condition in place, what we next need to do is check for the whether the L max is actually greater than the current height L. If it is greater, for example, there's a leftmost building which is currently greater than our current height, we could simply add the difference. That is, for example, if we are currently at this index and we the leftmost highest building is this, So we can simply add this 1 unit of water, that is the difference between the current height and the height of the L max. So we can do answer plus equal to L max minus height of L. And what else we need to do? If this is not actually true, what we need to do is that is L max is actually lesser than the height L or equal to. That way we can't compute the unit of water that can be trapped. So it will be L max is equals to height L, that is making and continuously iterating forward, because we are now done for this index. Similarly, for the right index, if this condition is not true, that is height L is not equal greater than equal to height R, what we need to do is we could do firstly for the right index and like close down the gap between both of them. That is starting from the left index simultaneously as right index simultaneously, and when the left index basically passes the right index, we stop the iterating. So else, if R max is greater than height R, what I need to basically do is add the remaining units of water to the answer, that is R max minus height R. Else, if it is not true, we know ki R max is actually lesser than or equal to height R, so we need to do else R max is equals to height R. And when we are done with both the conditions, we could simply decrease the right pointer to continue iterating. So yeah, and in the end, we could simply return the answer. Let's see if it is working fine. So it is working fine for the preliminary cases. Let's check for all the test cases. So it is giving 100% complexity. So basically what we are doing here is, let me explain again. We are starting from the left index and the right index simultaneously. If the height of left is lesser than height of R, that is, we know the right side of the buildings is basically higher. For example, this case, we know we can check for this side because the minimum side needs to be checked, because it would be the limiting factor to trapping the rainwater. The higher side won't be limiting it. So we first calculate for the left side. If it is not true, that is left side may be higher than the right side, we first compute for the right side, and then we move on to the left side. And when the left pointer crosses the right pointer, we know ki we can stop iterating, and we have computed for all the possible heights, that is heights of the buildings. So yeah, that's it. And the time complexity of this solution is O of n, because we are iterating the heights array only once. And we are using no nested loops or anything like else. We are iterating only once. For the space complexity, we are using constant variables and nothing else. We are using R max, L max, answer, and L R, that are pointers. So no extra space needed, only constant space needed. So that's it. Thank you.